Hello, Algebra 3, and welcome to your first class. You should have your prerequisite notes out and ready to go. That's your P notes is what they're called, like P1 right now. And on the top, it will say Algebra 3 or College Algebra. Just realize you are taking a college algebra course at about half the speed you would take it in college. So if you were taking this at college, which you should be doing next year, you would be taking college algebra, but it would cover it at double the speed we're going to cover it. So you should be very successful when you get there. So right now we're going to start our notes, and I do apologize. Your first section is longer than most because it covers a lot of stuff, but it is prerequisites, which is things you should already know. So if you have any questions, make sure you post them, and let's get moving. All right, here, this is everything we're going to cover in this section. So as you notice, there is quite a few things. It's not terrible. It just looks a lot longer than it really is. So we're going to evaluate expressions. We're going to use math models. We're going to talk about intersection and union. We're going to recognize subsets. We're going to do inequalities, absolute value. Remember the absolute value is distance. And we're going to remember or review some of your properties that you've had before. So have your notes out and let's go. Okay, your first part is an algebraic expression. So when you're looking at these, a variable is used to represent something, nothing too exciting. An algebraic expression just does not have an equal sign. When you evaluate, it's asking you to plug in a number for the variable and solve. Okay, an exponential expression means there's going to be an exponent right here is what we're looking at. So the first one, whoops, I don't even know how that did that. Sorry about that. So in your first one, it says, hey, I want to evaluate this expression at 13. That means you take the 13 and you plug it in for the x and you solve. I'm really asking, do you remember order of operations? So once you plug in 13, what do you do first? Do you add the 8 and the 6, or do you evaluate inside the parentheses? And you should know you evaluate inside the parentheses. So we take the 13 minus 3, step 1, which gives you your 10. Next, you must do exponents. So please excuse my dear Aunt Sally from when you were little. So 10 squared is 100. Then it's multiplication, so 6 times 100. And last is your addition. All right, pause the video and try yours. You should have plugged in the 5 for the x. So you should have started off with 2 times 5 squared minus 3 plus 5. All right, now you're looking at evaluating your parentheses. Well, there's nothing to do inside this parenthesis. This one here becomes an 8. So you got 2 times, technically you could have written 25 here, but I'm doing it all the way out just so no one gets confused. Now it's exponents, so 5 squared. So it's 2 times 25 minus your 8. So now you have your 50 minus your 8, your multiplication, and now your subtraction, which is always left to right or addition left to right. So your final answer should have been 42. Okay, next. All right, now I'm going to talk about equation. Remember, that's just when you add an equal sign to it. Formula is where you have variables involved. Mathematical modeling really is another name for story problems. Not all of those are real to start with because usually a story problem does not include the formula and you have to create it. If you look at our first one, they actually give you the formula. So the things that we know from reading is what we should write down. We know the formula T equals. So I know the formula already. I'm going to put it over here because we're going to use it right away. So the formula is T equals 4x squared plus 330x plus 3310. Okay, models the average cost of tuition and fees, T. So I know that T stands for tuition. All right, colleges for school, you're ending X years after 2000. Okay, so that's important. So I know X is years after 2000. All right. Okay, what I project the average cost of tuition and fees. So this is what I don't know. So this means I have to find It says project the tuition, so I'm finding T for the school year 2017. Well, so 2017 means that X has to be equal to 17 because it's years after 2000. So 2017 minus 2000 is 17. So what they're really asking me to do is plug 17 in for this X. So you're going to do 4 times 17 squared plus 330 times 17 plus 3,310. And that's going to be my tuition. All right, I'm hoping you just plug that in your calculator. So your tuition is equal to, let's see what that turns out to be. Okay, if I did my math right, $10,076. So that's just tuition. Now, if you Google this, so pause and do that, and you should have found an answer. I bet a lot of you got 17,000. Okay, the true answer is about 9,410 to 10,000, depending on which Google site you used. If you got, so that means my formula is fairly close. If you actually got the 17,001 or something higher, that was tuition plus room and board. Remember, room and board is where you live, and this is only a tuition problem. It does not include room and board. So be careful on what they're asking. Okay, next step. Now we're on sets. Okay, sets is just a collection of objects. All right, it always has parentheses. So I use numbers here, but a set could have been all colors. It could have said, hey, I have red, orange, and blue. That's a set. It doesn't matter. It's just a collection of objects. All right, if I list them out, that is known as a roster method or the roster notation. Okay, the 3 dots are an ellipse, which means it goes on forever. So this includes 6, 7, 8, 9, as far as you can count, which is infinity. Okay, set builder notation is another type of notation. It's read X, so that's a variable. This line is read such that. All right, X such that, X is a natural number less than 6. All right, that means that it's every number less than 6 and a natural number starts at 1. So if I had to write this out in roster notation, that would be 1, 2, 3, 4, 5. All right, roster notation, set builder. See the difference? Empty set means there's nothing in it. It can be written with this symbol, which is the null symbol, or it can be 2 sets of parentheses with nothing inside. Both of these are identical. Intersection is like an upside down U. This is what these 2 sets have in common. So they're in A and B. Union is a right U, is the way it looks. And that's what it's included in both sets. So it can be in one or the other or both. So it's all elements that are in A and B. And intersections is the elements that are in both A and B. So this is an and this is an or. So let's go down here and give this a shot. Try it, pause the video, and see how you did. Okay, what is the intersection? So I'm asking you for this symbol. Intersection means it's in both. So 3 is in both sets and 7 is in both sets. It asked you for roster notation, which means it wants a list. So you should have done 3, 7, roster notation. Union is what's in all of them, but it asked in set builder. I'm going to do it in roster just so you have a little bit better understanding. So roster is 3, 4, 5, 6, 7, 8, and 9. All right, so it's everything here. What they have in common, you only write once. Now, how do you write that in set builder notation? There's lots of different ways. I'm going to give you just one, and I'm going to use whole numbers. So we're going to say X, so I'm going to call these elements X, such that X is a whole number. Remember, whole numbers don't have decimals. Between 3 and 9 inclusive. Whoops. So it has to include 3 and 9, and that would give me everything in that set. You could have used the natural numbers. You could have done this a lot of ways. You could say it's a number less than 9 and greater than 3. Whatever you did is probably fine, but make sure you don't include any decimals in there. All right, let's go through our number sets just to make sure we remember. All right, and usually I tell a little story with this, so I think I will, even though I can't see you. We're going to use Jack and his little sister Sue. Okay, so Jack was born, and his mommy taught him to count. So when he was first taught to count, he learned 1, 2, 3, and he could count forever because he was a smart little boy. That's your natural numbers. It's naturally how you learned how to count. Now, Jack had a little sister. Her name is Sue. And Jack's sitting in his high chair eating his Cheerios, and along comes Sue, and guess what she does? She eats all of his Cheerios, and Jack is crying and mad. So the next number, which is known as the whole numbers, that Jack learned was 0. So now Jack learned a new number, 0, but he still knows 1, 2, and 3. So the whole numbers are 0 and 1, 2, and 3. So right now 3 is a natural number and 3 is a whole number. Good so far? Okay, now next, Jack's at the store with Mom, and he wants this candy bar, but he doesn't have enough money. So guess what Jack has to do? He has to borrow money from Mom. Now these are your integers. They have a weird symbol. It's Z. So now Jack has learned the negative numbers. He's $1 in the hole, or he's $2 in the hole, or he's $3 in the hole. Who knows? He's a lot of money in the hole. Good to this point? All right, now here comes back little Sue. And Jack is eating this candy bar. But guess what? Baby Sue is crying. So now Jack has to share his candy bar. These are the rational numbers. Their symbol is Q. He has now learned fractions. He's learned like a half, but it still includes a negative half. He's learned a third, and so on. But now remember that 1/2 can be represented with 0.5. All right, so it can be a fraction, or it can be a decimal that stops, but 1/3 is 0.3 repeating. So it can be a fraction or a decimal that stops, or a fraction or a decimal that repeats. Those are your rational. The next, this is what you learn when you get to school, are irrational, and those are actually IR. And those are numbers that don't stop or repeat. So you know some already. You know pi. It's 3.1415. Goes on forever, never repeats. Square root of 2. If you type that in your calculator, goes on forever, never repeats. All of these numbers are your real numbers. All right, now that we're done with our story, let's go on and see how you did. Here's my set. I want to know which one of these is a natural number. Well, I know this is when Jack learned how to count. He didn't know negatives. He didn't know 0 yet. He didn't know repeating numbers. He definitely didn't know pi. Square root of 9. Let's think about that. Square root of 9 is really 3. Jack knows 3. So a natural number, we're going to write this in set notation, would be the square root of 9, even though it looks funny. Square root of 10, I'm going to type that in my calculator. It goes on forever, so it doesn't count. All right, which one of these are whole numbers? Now remember, whole numbers, he added 0. So I got 0 in there. So 0 is there. Well, 0 also included all those naturals, so that also includes the square root of 9. All right, so well, that was weird. So that goes there. We're good so far. So we got whole number, we got that. All right, integers. That's kind of when Jack learned negative whole numbers. Let's see what we got here. Well, negative 9, that one counts. Why is this disappearing? Negative 9, negative 1.3, nope, still don't know decimals. 0, yeah, he knows that. Square root of 9, that has to be there yet. All right, that's all we get for integers. Rational, that's when he learned how to do those fractions. Well, rational, well, that still includes negative 9, because he still knew that. Negative 1.3 gets to be added in there now because you learned those negative fractions. 0 is still a rational number. Still repeating, so 3 counts. Pi, nope, pi still doesn't repeat, so that doesn't count. He still knows the square root of 9. And square root of 10, nope, doesn't repeat, doesn't know that. Irrational, now is the ones that don't repeat. So that one is just pi over 2, because he doesn't repeat, and it's just the square root of 10. See how those continually get bigger and how these two are completely opposite each other. Another way I could have asked this, I could have said, hey, what is the square root of 9? I asked you what the square root of 9 was. You would have to say, hey, that's a natural number. It's a whole number. It's an integer. And it's a rational number. Oops, that should have been in Q, my fault. Rational number. Technically, I should have stopped. Let's erase that. All of these are real numbers, and R is what means real. All right, just so you know when you're doing your homework. Okay, let's go on to the next. Inequalities, we have less than or equal to, greater than or equal to. Okay, absolute value is distance from 0. So this is always, positive. So the absolute value of A, when A is a positive number, so I'm asking like, what's the absolute value of 10? The answer is 10, so it's A. What's the absolute value of negative 10? Well, the answer is still 10, so it's always A. No matter what we do, the absolute value is positive. This here shouldn't be here, by the way. Absolute value of 3 is 3. Absolute value of negative 4 is 4. This actually gets messed up quite a bit, that's why I put it in here. You do not take the absolute value of both numbers and then do the answer. You take the absolute value, they work like parentheses. So you do the inside first and then take the absolute value of the answer. So 7 minus 10 is negative 3. The absolute value of negative 3 is 3. Okay, do yours. So you should have got this one because it's the same as above. While 4 minus 9 is negative 5, the absolute value of negative 5 is 5. Okay? Same thing down here. You have to take the negative 3 minus the 14, which is negative 17, and then get your answer, which is the 17. All right, so distance is, you just subtract the 2. Okay, try yours. So you should have done the absolute value negative 4 minus a negative 13. Well, that's really negative 4 plus 13, which is really 9. So the distance between negative 4 and negative 13 is 9. Distance between 5 and negative 2 is 5 minus a negative 2, which you should have gotten 7. The distance between 3 and 15 is 3 minus 15, which is absolute value of negative 12, which is 12. You could have also done 15 minus 3 because it actually doesn't matter which order you subtract when you're doing this. Okay, ooh, too far. Next on the list, and I am sorry this is long. If you need to pause and come back to it tomorrow, that's fine. Okay, your properties. Commutative means it just can flip the order. That works in addition and multiplication. So this one does order. Associative is grouping. So I can add the first two or add the last two and get the same answer, and it works in multiplication. Distributive is when you multiply through the parenthesis to every term on the inside of the parenthesis. Identity and these two go together. In addition and multiplication means you get the number or the variable back. So in addition it's 0, and multiplication it's 1. Addition property or multiplication property, when you add the opposite, you get 0. And when I multiply by the inverse, I get 1. All right, let's see if you recognize your properties. Pause and try these 4. Here you should recognize that the number stayed the same and the grouping changed. So this is associative. Here it looks like grouping, but it really isn't. The numbers changed spots, not the group. So this is commutative. Here you're multiplying through the parentheses, so this is your distributive property. Here you got the same number back, so you know that is identity. If you want to do addition and multiplication, that's fine, but these are what I really and truly am going to look for. All right, simplify this. Let's see if you remember how. Come back and let's see how you did. So you should have said that's 28x squared because you're distributing the 7 plus 21x. I put this in here just to see if you remembered your negative. You're actually distributing negative, so that's negative 10x squared minus 2x. Now you're combining their like terms. So 28x squared minus 10x squared, and you should have an 18x squared. And then you're going to take the plus 21x minus the 2x, which should have given you plus 19x. Did you do your signs right? Or did I mess you up? Okay, that's it for this lesson. Do your homework. Make sure you post on the discussion board so you get credit for everything, and let me know how you're doing. Talk to you later.